Hey guys, welcome back to the show. I hope you've been enjoying it so far. Remember, we're busy with analytical geometry for grade 12. Guys, I really want to mention this app. There are some more features on the app that you can now have a look at. The app is available on Android and iOS. It's free to download, and we've got a new feature which added to the app. It has a live show feature. So guys, that means that you can watch this show from wherever you are. It does take a little bit of data, but you can watch the show from wherever you are. So at the moment, I know that my fiancée, Jeandre, is busy watching the show. She doesn't have DSTV, but I guarantee you she's watching the show with me because of this new feature that we've got on the app. So I'd like to thank Liberty for sponsoring this great app. Guys, it really does help you before you write your cycle test or your exams under the assessment section. So go, guys, have a look at that app, go and download it, and we really appreciate that. We're going to carry on with some questions. We've got a question from Luandile today. Let's have a look at what the question is.
Hello guys, my name is Luandile. I'm from Tswat Secondary. Can you please help me with this question?
Okay, Luandile, thank you for that question. I've got really great news. You have just won yourself a 19-inch TV. So congrats to you. And guys, it's as simple as that. If you want to go and win a TV, send in a question, take a little selfie with your phone, your camera, take a video, and then send it to our WhatsApp line, and we'll have a look at it, and you can put it on our show, and you can stand the chance of winning a TV just like Luandile. Let's have a look at what the question is. So the question says as follows. In the figure, MN is a chord of the circle with center O. It says that the diameter POT is parallel to MN, and points M and N are -3 and 1, and 1 and -3 respectively. And we have this lovely diagram over here for us to reference. The first question says, find the equation of the circle. Okay guys, so if you've had a look at some of the videos that played before the show, there's two types of equations that we have for a circle. We've got an equation for a circle when it's in the center of our Cartesian plane. We've also got an equation which we dealt with in the previous question where my circle has been shifted around and the coordinates of the center change. If we have a look at this question, our center is exactly in the middle of our Cartesian plane, and that makes things a little bit easier for us when we find the equation. So if our circle is in the center, my new equation then becomes x squared plus y squared is equal to r squared. Okay guys, so at this point, we just need to find our radius, and there we've got it. We've got our equation for our circle. So what we're going to do is we're going to substitute in the points, or one of the points that we have. So I'm going to substitute in n because n is on my equation of my circle, and that goes through to the center. So if we substitute in my value for n, it is 1 for x and -3 for y. So we're going to say then that 1 squared plus -3 squared is equal to r squared. So if we do this quick maths, we're going to have 1 plus 3 squared is going to be 9, and that's going to give me r squared. And we can therefore say that r squared is equal to 10. Okay guys, so finally our equation is then going to be x squared plus y squared is equal to 10. Simple as that. Okay, let's have a look at the next part of this question. It says here, find the equation of the diameter POT. Okay guys, so we got POT. Now if we go back and we remember what the question said, it told us that the diameter is parallel to the other line that was given to us, MN. Now when we have parallel lines, we must then straight away think that our gradients of our lines are exactly the same. So if we find the gradient of MN, we can then find the gradient of our diameter POT. So that's our first step that we're going to go for. We're going to say then my gradient of MN is equal to y2 minus y1 over x2 minus x1. Okay. Guys, I want to mention something over here. I've written down y2 and y1 and x2 and x1. When it comes to substituting into the gradient formula, you don't want to mess those around when it comes to choosing your different points. So if I've got y2, I then need to sub y2 first, I need to take that coordinate and have it for x2. If I mess those two coordinates up, I'm then going to get the incorrect gradient. So what I like to do is, let me circle what my y, this is going to be y2, that's going to be y1, and this will be x2, and that'll be x1. So if I substitute this in, I'm going to have then 3 minus my y1, which is going to be 1. I'm then going to have x2, now my x2 is going to be 1, minus negative 3. If I simplify this, I get 3 minus 1, which is going to be 2. And if I divide, well, it's going to be 3 minus plus 1. Let me just have a look over here. Oh, guys, sorry. See, guys, this is really important. I've just made a sign error over here because I'm not paying attention to my coordinates. So, guys, when it comes to this in analytical geometry, pay careful attention. Okay, I'm going to slap myself. So, guys, this over here, y2 is negative 3. It is not 3. So, I'm going to have negative 3 minus 1. And that's going to get me not 2, but instead it is going to get me negative 4. And then I'm going to have y1 plus 3, and that's going to get me 4. And I'm finally going to have my gradient equal to negative 1. Okay, guys, so I've got my gradient. If you look at that line POT, it goes through the origin. So that means I don't have a y-intercept, or my y-intercept is going to be equal to 0. So I can straight away say that my equation on my straight line is going to be equal to y is equal to negative x. Let me write that down. So we're going to have y is equal to negative x, and that's going to be my equation of POT. Okay, let's move on for this next question. So we're going to have calculate the coordinates of PT, and it says leave your answer in surd form where necessary. Okay, guys, so what that means, a surd form means that we've just got a square root or a cube root or some sort of root in our answer, and instead of using our calculator to simplify that, we just leave it as is. Me personally, I like to leave answers in surd form because it's accurate and you don't get decimal places. So if we do this, we want to calculate the coordinates of P and T. Well, guys, we had our equation for our circle to be x squared plus y squared equals 10. And we also know that y is equal to negative x. If we have a look at our coordinates on our circle and our line, those are 2 points that touch. Now when they touch, guys, it becomes a simultaneous equation. We equate one equation to another equation to try and find those points. So this is what we're going to do. We're going to substitute in negative x for y. So we're going to get x squared plus negative x squared is equal to 10. We're then going to get 2x squared is equal to 10. And straight away we can say that x squared is equal to 5. And if we want to solve for x, we get x is equal to positive or negative root 5. Okay, guys, so as you can see over there, I've got a root. They told me to leave it in surd form, and that's exactly what I'm going to do. We got two answers. We got positive and negative root 5. And that just tells us that we are having 2 points for P and T. If we then have to solve for my other coordinates, well, we know x is positive or negative root 5, and we have this equation over here which is useful, y is equal to negative x. So my y coordinates are then going to become the opposite of this. It's going to become negative or positive root 5. So if we go back up to my diagram, we can see that P is in a quadrant where x is negative and y is positive. So we can then say that P is going to have the positive root 5 value, and it's going to be, sorry, I lied. I just said it has a negative x, and I just put positive. So it's going to have negative root 5 and a positive y value of root 5. T, on the other hand, you can see that it is in a positive x quadrant and a negative y quadrant. So we are then going to say T is going to be root 5 and negative root 5. And that's that over there. Okay, let's carry on and see what the next question is. Okay, so it says here, if E is a point on MN such that OE is perpendicular to MN, give the coordinates of E. Hey guys, so when it comes to this over here, there are tricks or little tricks that you can do when looking at these types of questions. This question in particular, there's two ways to solve it. We can do another simultaneous equation, which is going to take us really long to try and find this point. But guys, they give us a little bit of a clue in this question. They mention the point perpendicular. So if it's perpendicular, we then know that our gradient of our one line multiplied by a gradient of our other line is then going to be equal to -1. But guys, like I've just said, I don't want to do this with this sort of question because it's going to take us a really long time to try and find the answer. What we're going to do is we're going to bring in our knowledge of Euclidean geometry. If we've got a chord on a circle and it's perpendicular and it runs through the center, what do we know about that chord? Well, that chord is then bisected. So if it's bisected, guys, that means we can find the midpoint of that chord. And to find the midpoint is a lot easier than doing more simultaneous equations. So let's have a look at what we're going to do for that. We're going to have then, if we've got some line that goes perpendicular to the chord, it bisects that chord. Okay? So this over here is a Euclidean geometry theorem that you can use when trying to solve for these types of questions. So we know then that my point E is going to be the midpoint of M and N. Now my midpoint formula, guys, of Mn is on the formula sheet and it's going to be the following. x2 plus x1 over 2, y2 plus y1 divided by 2. Now if we substitute in these 2 points over here, so my x2, I'm going to have it as 1, and my x1, I'm going to have it as -3. So plus -3, and I'm going to divide that by 2. My y2, I'm going to have as -3, and I'm going to add my y1, which is going to be 1. And I'm going to divide that by 2. This is using my midpoint formula. Okay guys, so 1 minus 3 is going to get me to -2, and divide that by 2. And then we're going to get -3 plus 1, which is going to get me -2, and we're going to divide that by 2. So if we simplify this, this is going to be my coordinate for E, which is then going to be -2 divided by 2, which is -1, and -2 divided by 2 again is going to give me -1. And if we have a look at our diagram, guys, does this answer make sense? Well, yes, of course. We are in a quadrant where my x is negative, and we're in a quadrant where my y is negative. So we can then say, well, that is going to be -1 and -1. All right. So guys, that's the end of this question. It was a really nice question. You bring in your concepts for Euclidean geometry. It does help make analytical geometry a little bit easier when it comes to sorts of questions that involve chords as well as tangents and all the other things that go with it. So don't forget your Euclidean geometry. Guys, we're going to take a quick break and then we're going to be back in studio answering some more of your Euclidean geometry questions. Your analytical geometry questions. Now guys, stay tuned.